When first studying physics many years ago, our instructor posed this question. A rectangular barge, 300 centimeters long and 200 centimeters wide, floats at the edge of a freshwater lake. A horse jumps into the barge, and the barge sinks 12 centimeters. How much does the horse weigh? Solving this problem makes use of knowledge created by the Greeks over 2,000 years ago. Archimedes' principle. Archimedes investigated density and buoyancy. His millennia-old discoveries are still used today by marine engineers and ship designers, and we will use it to solve the horse problem. Before we start, a quick comment on units. In science and engineering, the terms mass and weight mean different things. Mass is an intrinsic property of matter, and weight is the force of gravity acting on an object. But the term weight is commonly used to describe mass. We say, for instance, that an apple weighs 500 grams, even though grams are units of mass. I will be using grams in this basic investigation, recognizing that a rigorous procedure would require units of force. If you have viewed our video on buoyant force, you will know that objects sink or float based on their density relative to the density of the fluid they are immersed in. This wood block is less dense than water, so it floats. Or at least it floats partially submerged. The submerged portion of this wood block has displaced some water, pushed it out of the way. Let's investigate this displaced water. To collect the displaced water, I have created this overflow apparatus, a tub with a spout. Filling the tub over the spout, we will let water run out until it stops. The surface of the water is now level with the overflow spout. Before we start, let's weigh this wood block. It has a mass of 266 grams. Our overflow tub is ready for use. We have an empty cup on a scale positioned to catch and weigh the displaced water. The weight of the cup has been subtracted. When we lower our block into the water, displaced liquid starts flowing out the overflow tube. The scale is weighing this displaced liquid. After a few minutes, the flow slows and eventually stops. The scale indicates that the displaced liquid weighs 266 grams. Do you remember the weight of the wood block? It was also 266 grams. The floating wood block and the displaced liquid weigh the same, 266 grams. This is not a coincidence. This is Archimedes' principle. The weight of the displaced liquid equals the weight of the floating object. Or, more precisely, the buoyant force acting on a submerged or floating object is equal to the weight of the displaced fluid. Our floating wooden block weighs 266 grams. The water displaced by the floating block also weighs 266 grams. We know that the floating wood block displaces its own weight in water. What happens if I add a weight to this floating block? Like this 126 gram stone. The wood block sinks further, displacing more water. Can you predict the weight of the water displaced by the stone? Did you get 126 grams? That's right. The additional weight of the stone caused the block to sink further, displacing a weight of water equal to the weight of the stone, 126 grams. Now to solve the horse problem. We have a rectangular barge measuring 300 centimeters by 200 centimeters, sitting in a freshwater lake. A horse jumps onto the barge, causing the barge to sink 12 centimeters. How much does the horse weigh? Like the stone sitting on the wood block, the horse has displaced water equal to its own weight. We need to calculate the weight of this displaced water. If you think you know how to do this, pause the video and do the math. The barge, before the horse is loaded, is sitting at this level. It has displaced water equal to its own weight. When the horse jumps aboard, the barge sinks another 12 centimeters. The volume of water displaced by the weight of the horse is a rectangular prism. 300 centimeters by 200 centimeters by 12 centimeters. The volume of a rectangular prism is length times width times height. That's 300 centimeters times 200 centimeters times 12 centimeters. This equals 720,000 cubic centimeters. This is the volume of the displaced water. Now we need to calculate its weight. Fresh water has a density of 1 gram per cubic centimeter. This means that 720,000 cubic centimeters of water weighs 720,000 grams. Let's change this to kilograms. 1 kilogram is 1,000 grams. This means the displaced water weighs 720 kilograms. The horse weighs 720 kilograms, the weight of the water it displaced. Archimedes' ancient principle is still used to determine how far a ship will sink when loaded with cargo. The math involved in this calculation is very similar to the math we use to determine the weight of the horse. This millennia-old principle describes the forces affecting everything from hot air balloons to cruise ships. More science and technology projects and videos can be found at our website, hylaroad.com. Follow the projects link.